Good morning, friends. Welcome to the session 7 of Resilience4j Fault Tolerant Library. Thank you for watching my previous sessions, and I got a very valuable feedback as comments. Okay, in this session, we are primarily focusing on monitoring the events. Okay, so monitoring our fault tolerant events, like whether it can be a rate limiter event, whether it can be a circuit breaker event. So those events are important for us to monitor because they give insights into our system. So to keep it in a very simple sense, let us say like if you have watched my previous videos, so you know circuit breaker very well, but here I'm also dealing with the same. So in this example, this is like a reiteration for the people who already watched. Okay, in this example, what I have is I have a ServiceA microservice which is calling ServiceB, and the response it takes from ServiceB and send it back to the customer. So that's our scenario. So ServiceA is going to call ServiceB and takes the response and give it back to the customer. It's nothing but a greeting message. It says it takes greeting message from ServiceB and sends it back. But for some reason, the ServiceB is a faulty service. Like if you send request to ServiceB, 50% of the requests are going to fail. So what's the thought process here is, instead of sending the failure message to the customer, we will send the messages from the cache. Whenever the service B is experiencing any failures, instead of calling service B repeatedly, service A is going to send messages from the cache. That's what we have done. So we achieved that in a very simple sense with circuit breaker. I'm not going to explain the circuit breaker here. But circuit breaker pattern helped us to achieve that without writing any additional code. With a simple annotations we were able to do. That's fine. But the real challenge comes here is like whenever a circuit breaker pattern applied, okay, like the circuit moved to various states, right? It can be open, half open, and closed state. We need to monitor. That helps us. That helps us to understand how well the system is behaving, like how well the service B is behaving. For example, the system, the circuit breaker, the circuit breaker is in a open state, right? So when a circuit breaker is in an open state, then there is no calls go to service B. So you have to see them, right? So you have to see those events. So here what we are going to use is, here we are going to use Prometheus and Grafana as a monitoring systems. Okay, like Prometheus is a true monitoring system. Like every time it is going to get the circuit breaker events metrics from the JVM. So when I explain you in the diagram, it will understand. Like then we use Grafana for our visualization in the dashboard. Like you have a nice dashboard which will explain you what are the events, circuit breaker events or rate limiter events happened in your microservice landscape in your application, so that appropriate actions can be taken. There are two ways. Okay, like when an events generated, you can have a dashboards or you can have alerts created. So few people ask me, why can't we monitor our circuit breaker events using Elasticsearch stack? That's also good, fairly nice idea, but using Elasticsearch to monitor the circuit breaker events is not a better pattern. That's what I feel, because they have a very good integration with Prometheus, and you can use Grafana as a monitoring tool. And the main problem here, what I'm seeing is every time the circuit breaker events comes, right, there is no listeners to write a log message for you. Like when a circuit breaker moved from one state to another state, like closed to open, half open. So when a circuit is in a closed state, you want to know when a circuit is in an open state. You want to know when a circuit is in a half open state. You want to know. So to log those events into the log messages, then you have to do aggregations on your index in Elasticsearch and show it in Kibana. It's a really complex thing. Instead of that, you just use Prometheus and Grafana as your visualization. It's a lot trivial. That's what I felt. Okay, so now let us go back to our agenda. So why do you want to monitor Resiliency4j events. You implemented circuit breaker. That's fine. That is coming into action whenever something goes bad within the service B. But why do we monitor? We want to monitor, right? How many times the service B is really became bad. Okay, how many times my circuit breaker is moved to one state another state, so that you at the end you have to fix service B, right? So that's the reason you want to monitor them. Not only monitor them, when you monitor them, you can take appropriate action. Okay, for some reason the service B is not recovering at all, you need to send an email alert so that people can take appropriate action. So those things you can do. What is monitoring? It's a very broad discussion, but here in the sense what happens is we will see the changes in the system, we'll observe the changes that are happening in the system. Probably this is may not be a straight or Wikipedia definition, but monitoring is very essential. Though you have poorly written code, that is fine, but it's poorly monitored code is very bad. You need to have really good monitoring system. If your code is performing poor, that's fine, but if you don't monitor what is happening, then you really don't know what's going on. So Resiliency4j exposes metrics in the when I'll explain you. Then what is Prometheus? Prometheus is like a monitoring, and Grafana is like visualization. We integrate both Prometheus and Grafana to do that. Okay, let me jump on to the whiteboard. I'll explain you the architecture what I have, and as usual, this entire, as a standard practice, this entire tutorial is documented in this Git repository, Resiliency4j Hello World circuit breaker error calls with Grafana and Prometheus monitor. So you can clone this Git repository and you get everything. Before delving into that, I'm just going to explain you the architecture and stuff. So let me open a whiteboard. Okay, what I have is I'm running, sorry. So I'm running on Windows 10 base OS. My base OS is Windows 10. Then I have one Linux virtual machine, because I run Grafana and Prometheus in Docker inside Linux virtual machine. So I have Docker. I'm not going to say about what is Docker, so you will easily understand. There are several good videos in internet. Then I have Prometheus here, and then I have Grafana here. So essentially I'm running Prometheus and Grafana, okay, inside the Docker. So what then I have on my host operating system on Windows, I have ServiceA and ServiceB, SB, ServiceA and ServiceB. This is ServiceA and this is ServiceB. ServiceA is calling ServiceB. Okay. So what happens is, when a user, you already know the flow, right? When user calls from browser, something from browser or API call, when someone calls a service A, service A is going to call service B. And if there are so many errors beyond the threshold, then it will send the messages from the cache. If you see my previous circuit breaker pattern, you will understand. So I'm not going to explain how circuit breaker on errors works. Here what we are going to see is we are going to get monitoring information. We are going to get events of circuit breaker or resiliency for Prometheus is going to call service A. So like service A has an actuator endpoint, very standard way to expose metrics for a Spring Boot. Okay, actuator slash, I think it is Prometheus. Okay, so actuator slash Prometheus is a REST API. So Prometheus is going to call ServiceA REST API, which is nothing but actuator called Prometheus, to get the metrics. So the metrics is retrieved, and what Grafana is going to call is Prometheus and show those metrics in the visualization. That is what you want to understand. Prometheus is going to call ServiceA to get the metrics like Resilience4j events. Probably I use metrics and events as a synonyms. There is a subtle difference between them. Okay, so Prometheus is going to call ServiceA to get the Resilience4j events using a REST API actuator / Prometheus. Similarly, Grafana is going to call Prometheus and get that information and show it in the UI. Now, for so Prometheus runs on the port 9090 and Grafana runs on the port 3000. So I just do a port forward of both from my virtual machine. If I want to access Prometheus and Grafana, I need to access their ports, right? I just did a port forward of those two processes there. Similarly, what I did is I just did a reverse port forward of 8080 port here. So Prometheus is need to call the service here, right? So I did just a little bit of port forward. These are all needed when you are running it in a Linux virtual machine. But when you are running everything in a single host, you really don't need this network port forward and stuff. Essentially, what I want to say is like Prometheus should be able to call ServiceA and Grafana is able to call Prometheus. Make sure that that whole network is established. So this is what I did a little bit of port forward, and to do that my document explains you, but for a simplicity sake I'll just explain one more time. So Prometheus is forwarding 9090 port to Windows 10, and similarly from Grafana I'm forwarding 3000 port to Windows 10 machine. And similarly Prometheus, which is running in Linux, right, it has to access the service that is running on Windows machine. So I also do a port forward from here to here. That is what 8080. Just remember like that. Okay, so like Prometheus is going to access 8080 port on Linux VM, but it's not really running it on the ServiceA is running it on the Windows 10. So a little bit of port forwarding, if you don't understand, that's perfectly fine. If you are run all the components on a single machine, that should work. Now, this is what little bit of whiteboard drawing which I have did. So the same thing I try to explain in the architecture diagram. So browser or JMeter, I use JMeter to generate the load. So with browser calls get greeting method where service A is going to call service B, and similarly the service B is going to return and the error message is returned. The circuit is going to open on errors. If the errors are above 50% in the past 5 calls, if 3 calls fails, then circuit is going to go to open state and the calls are not going to be. So these events you need to monitor. I have here, okay. Prometheus runs on 9090, Grafana runs on 30. You can access Prometheus localhost 9030, and the Prometheus need to call the service A, right? So call the service A for the events. It is going to call actuator / Prometheus REST service, which is having 8080. Okay. Now, as a standard practice, you can clone this Git repo. Then the first thing what you need to do is vagrant up. I'm having a Linux machine. You just do vagrant up. Then the virtual machine starts and necessary softwares, Docker, everything gets installed. So if you want to see that it's what is it in a vagrant file, let me open that. So nothing great. So I just rub greatest CentOS 7 box and I just do a port forward of 9000 and 3000 ports, and I have a startup script to install the Docker and everything on the plain vanilla CentOS machine. So that's what that will do. So if you see, This is the startup script which will install the Docker and the necessary utilities for you. Okay, so that's how, if you have Docker, then you really need not to do everything. So now Vagrant up will bring the virtual machine up. I already have virtual machine up. Then what I need to do is I need to take SSH to the machine. So I said, right, Prometheus will be running inside the Linux VM. It has to call the ServiceA running on Windows. That's the reason I do a reverse port forward. If you don't understand, that's also fine. But when you have whole the network, it's very easy. So I'm taking SSH to it. Then now my first goal is I'll bring Prometheus and Grafana up and do the configurations. So that is my first step. Now I brought the Linux CentOS Mission 7 up. Now I'm running the dog. Now I'm running Prometheus and Grafana's sudo su minus. Let me switch to root. Then I have Vagrant. Then Resilience and circuit breaker error calls Grafana monitor. Okay, so I'll show you, I'll use Docker to bring Prometheus and Grafana. Okay, so let me walk you through the Docker compose file. So these are two services. One is Grafana and another one is Prometheus. Okay, I'm bringing both of them up. Then you can see that Prometheus.aml file, which says what are the configurations that Prometheus needs to take care. So what our Prometheus is to take care, our Prometheus is to call the ServiceA and get the metrics, right? That is what it's. So that is what I'm going to define in Prometheus.aml. Grafana env, nothing. Well, Grafana comes up, we'll do the configuration. So now the first thing what I'm going to show you is the Prometheus configurations as well. So in Prometheus configuration, I said this is my path, this is my job name. So Prometheus is like a job. Okay, every 5 seconds it's going to call the ServiceA for all the events, all the metrics. Okay, so /Prometheus, and this is the target. This is a URL, or this is a scrape URL. Few people call it a scrape. So every 5 minutes it's going to scrape the metrics. It's going to ask to give the metrics and put it in its internal store. So this is what the scrape config for Prometheus. Simple thing is Prometheus every 5 seconds take metrics from ServiceA. This is what we define from here. It's a job name ServiceA and metrics path and the URL. Okay, now what we'll do is Docker compose up -d. So let's bring, let me see whether I already brought the system up or not. So it's not up. Docker compose up -d. Docker compose up -d means it will download all the Prometheus and Grafana artifacts and start them up in a daemon mode. -d means daemon mode. Don't bind to any IO. So good, our Grafana is up and our Prometheus is up. Let us check the Prometheus first. http://localhost. We have Prometheus running on 9090, right? So you can go to status targets. Okay, and let us do a refresh. So it is saying that it is able to reach the ServiceA and it is up. So let me check whether did I started ServiceA. I think that's a big mistake I have done. Else, because we still didn't start the ServiceA, right? Okay. So down. That's a behavior because it is going to call ServiceA for the metrics, and currently ServiceA we didn't bring up, and it shows the ServiceA is not there. Okay. So Now let us bring the whole service up. Then we will configure monitoring. That's very easy to see in a nice visualization. The first thing is like as usual, you git clone, then you do a maven clean install, clean and build the code. Okay, then you are going to bring ServiceA up. It's a very standard thing. Java-George ServiceA up. Okay, similarly bring the ServiceB also up. So I'll follow the same pattern, ServiceB target, and this is how you can bring the ServiceB. Now the ServiceA up, ServiceB up. Now let us configure Prometheus to read the information from ServiceA, events information. Then you configure Grafana to call Prometheus and see what are the circuit breaker events has happened. So these two instances are also up. These two are also up. Let us finish the configurations. Now Prometheus, let us see what it says. Okay, it did a scrape and it says it's up. Or go to Prometheus Explorer. Here it can see it is able to get these many metrics from our ServiceA. Like we are more interested into circuit breaker state, right? What states the circuit breaker moved and stuff. So here you can see currently the circuit breaker is in a closed state. That's a known thing for us. Okay, right? So now let us generate some load and see what's happening. So I'll use JMeter to generate or to call our ServiceA. Open recent Resilience4j volt. This is a very standard thing you might have seen. I always use JMeter, and I'll say I'm going to run this for infinite time. One user is calling infinitely ServiceA until I say to stop him. So now let me run. So obviously fails is going to happen. Like you see, ServiceB generator exception, circuit breaker is in an open state, but you don't monitor them logs, right? It's very difficult. You need to have good monitoring tool. So let me see Grafana and see what is the circuit state. And now the circuit is in a open state. Okay, so when a circuit is in open state, the calls are not going to ServiceB, and you are monitoring them with Prometheus. This is good. You can monitor them with Prometheus. You can check them in logs, but this is not the way the real world work, right? You need to have a visualization, UI dashboards in a command center. People have an eye on it, what's happening. So we need to have a good visualization tool like Grafana to show the UI. Now, I'll stop my service. Okay. So probably now what happens, let us see. So circuit I automatically move to the closed state. Okay, so there should be a half open state also. We'll see. So currently it is in a closed state. Now let me do a few calls, then execute the graph. I think it takes time for the Prometheus to get those metrics. Okay, so now what we will do is, it's very tough. You always use Grafana to just view them. Okay, let me see it once again. It moved to open state. Every 5 seconds, if I have reduced my scrape interval to 1 second, then the refresh rate would have been better. It's like the more every 5 seconds only it is going to call the ServiceA to get the events. Now this is good. Let us go back and view these changes in the UI. I built a nice dashboard. So let me go to Grafana. So Grafana is logging on 3000 by default. Grafana password, username and password is admin. So now it is asking to change the password. I'll give same admin. Okay. So now the Grafana is up. If you go switch back to our architecture, the Grafana is up, which is running on 3000 port. Now what we will do is, now we will configure Grafana. So the Grafana has to get metrics from Prometheus, right? Prometheus is source for the Grafana. So I'm just go to configurations and go to data sources. Then add a data source. I'm saying Prometheus is a data source. Select it. Okay, Prometheus is running on localhost 9090. Okay, localhost 9090, and it is able to reach from the browser as well. So I said from browser we are able to reach the Prometheus, right? So I just selected browser, save and test. The data source is successfully added. Now what I'll do is I created one dashboard for you. I'm going to import that and show you. So import the dashboard. I have a JSON file. The JSON file is also there in the repository. So I have it in Resilience4j monitor. So there is a dashboard circuit breaker. In the source code there is a dashboard.json. You can open it and I'll just import. So you can see the nice dashboard here, right? I'll explain you. The application we are trying to monitor is ServiceA. Good. How many instances of it? We have only one instance. If I have 2-3 instances of ServiceA, I can have. So which is running on 800. I'm only monitoring one circuit. What is like greeting circuit? Like we can have rate limiter circuit. You can have bulk header circuit. So you can have those many circuits. Currently, I'm interested in only in the circuit greeting circuit. Okay. So currently it is in open state. Why it went to open state? Because 67% of the calls are failed. So if you see, this is the failure rate is very high, right? So this is nicely showing that 67% of our calls are failed, and current state is in open state, and it sometime back it went to closed state as well. So let me stop and wait for some time, as we expected, right? As per our Grafana configuration, as per our circuit breaker configuration, as per our greeting circuit breaker configuration, so it needs to wait for 10 seconds. It will wait in an open state for wait duration in open state is for 10 seconds. So it will wait for 10 seconds, and after that it will go to the half open state, and then it goes to the closed state. So let me do a refresh. So it went to the closed state, right? So because that's an behavior, and currently there are no calls going, so there is no information here. This is a nice dashboard you can view. Okay, I'm not going to explain about the circuit breaker, but I'll show you how the event. So I said you right, Prometheus is going to call REST API, which is nothing but http://localhost:8080/actuator Prometheus. You see here, these are the metrics. This is how the this is how the Prometheus is taking metrics from ServiceA, which is nothing but our ServiceA Tomcat. So these are all the metrics. So you can go through this. It's very tough, but it's really tough for us to infer something on this. So Prometheus reads it every 5 seconds, updates its data stores, Grafana shows it in the UI. So that is what we did. Now coming back to how do you enable this monitoring on your Spring Boot application? So that's thing as usual, we have a one pom.xml. So include this micrometer dependency. Micrometer dependency is nothing but instrumentation. It will instrument your Java code and expose the Resilience4j metrics as a Prometheus metrics. Then Prometheus can read it. Okay, so we really didn't do that. You just add simple this dependency. That's enough. And say to the actuator framework that you are exposing all the circuit breaker, rate limiter, tags. So these all information you are exposing, you can say it in application.yml. So we have this application.yml. These are the only two things. Add a dependency and say that you are exposing these metrics in application.yml, then everything is done. Then have Prometheus scraping the ServiceA, then have Grafana calling the Prometheus for the visualization. So in this tutorial, I didn't show you I didn't have a alert rules configured. Like if the circuit is in closed state for more than 1 minute or 2 minutes, send an email alert. That's bad because the ServiceB is still bad. Then someone has to take care of ServiceB. Ultimately, we shouldn't return results from cache, right? So if you want to have those rules, you can define roles in Prometheus where Prometheus can send it to email or your subsystems integrations are there. I didn't cover that. So I was planning to do entire session on monitoring with both Prometheus and Grafana, where the JVM host monitoring, JVM monitoring, alert rules. Okay, when I cover that, I'm going to show you. As I said, right, poorly written code is to some extent acceptable, but if you don't monitor your environment, you really don't know what was happening. Okay, so you need to have a good monitoring system. That's the reason I stress more on this topic now. So now let me go back to my previous slide. Did anything I missed? I think I demoed everything. So, but so this is not my entire merit. Okay, I didn't do this on my own. I just took it from various GitHub repositories and various books I referred. So I want to acknowledge few of the beautiful library repositories. Okay, learned a lot from Bladung. Okay, site. Okay, then the actual Resilience4j, they have a demo Git repo, which is like far superior. It has everything. But to understand it takes a little bit of effort and time. So then I used their getting started guys. Then I went through Prometheus and start reading Prometheus and understanding it. So this is a nutshell. The purpose of this session is like to make everything simple and bootstrap you. You need to get quick list. You need not spend much time on configuring, installing Prometheus, installing Grafana. And this is like one simple Git repo. You just start, play with. You have a JMeter test library to generate the load, then events generated. You can monitor with Prometheus and Grafana. So yeah, I thought I'll finish this Resilience4j series with this video, but I got one of the requests from one of the follower asking me to make one more video on I forgot the topic. Okay, on the slowness, I believe. Okay, so there will be one more session which I'm going to do, and with that I'll finish this whole fault tolerant library. We learn from end to end all the patterns, monitoring, and hope you liked this session. Thank you for watching.